Good morning, everyone. I'm Greg Hankins from Brocade, and I'm co-presenting with Brent Van Dusen from Limelight. We're going to talk about some operational issues and some considerations for 100G networks. And this is kind of, I think, the first talk that I've done together with an operator. Typically, it's been me talking about what's going on in the standards organization, which has varying degree of interests. I found it very interesting. I hope you did too as well over the past couple of years. But now that the standard's actually done last summer, and we have shipping products on the market, I think it's time to talk about some things that people are thinking about when deploying this new technology, because it is available now and people are actually deploying it. So this is kind of the general agenda. I'm going to talk a little bit about what's going on in the industry. Is there a lot of feedback on this mic? Okay, I'm going to talk about what's going on in the industry, and then maybe I'll stand back a little bit. And then Brent's going to talk about some of the things that they're thinking about as they start to consider deploying this technology. So basically, I started to kind of take a look back and think about, what problem are we trying to solve here? And this kind of applies to any lower speed interface that's transitioning to a higher speed technology. So the same thing applies going from 1 gig to 10 gig and 10 gig to 100 gig, things like that. But basically, I've been in a lot of meetings with customers, and people have literally come out of the woodwork interested in 100 gig. So there's a lot of applications that maybe we don't think about traditionally in an ISP or service provider network. Basically from the core to the edge and metro, a lot of interest from high performance computing folks that are trying to build these CLOS interconnects that provide the same bandwidth to each end station over a cluster, and then also obviously in data center applications too. Basically, I think LAG's done a really good job for us in terms of solving problems, but it only goes so far, and there are a number of issues with lag and ECMP. And then the side effects that I like to remind people are that as we move to a denser new technology, the lower speed technology is going to become even more dense, right? So if we have a 100 gig interface, that's at least a 10 by 10 gig interface on the same card if the capacity is there. So basically, like I said, lag and ECMP have been around for a long time. It's a great solution for a lot of people, but it doesn't solve every problem. We have a lot of scalability issues in terms of the number of lags and then the number of links in a lag. So in terms of scaling up the number of links in a lag, you have to have resources to run LACP. Now we see requirements, for example, in large data centers where they want to dual home servers. So we have people asking us for several thousand LACP sessions, so that can get kind of taxing on the CPU. And then as you scale up also the number of links in a lags, the hashing becomes extremely complex. So you have to do a really good job of obviously distributing that data over each link in the lag, or else you get a lot of lumpiness. And then the other problem really is that hashing is decoupled from link capacity. So there's only one proprietary vendor implementation that I know of that actually pays attention to how much capacity is on the link, but basically the hashing algorithm can't tell, or the link can't tell the hashing algorithm when it's full. So the hashing algorithm basically hashes as fast as it can and sprays packets over the number of links in the lag, and then if it's full, then there's packet loss. There's a couple problems with flows. I think one of them we aren't going to see. There's the whole problem where people are talking about, well, we're going to have 10 gig flows. I haven't seen anyone putting out 10 gig flows today. That'll probably happen in the future, but I think the problem that we do have right now is that there are lots of large flows that could exceed the capacity of a link. So I know that people are sending out, for example, gig flows, and if the hashing, so if you're an internet backbone provider, for example, you probably have a very diverse number of inputs and outputs for your hashing function, and you have a lot of different packet sizes. So if the hashing is a little bit lumpy, it's probably not the end of the world. But if you have gig flows that you're trying to hash onto a 10 gig link, for example, and the hashing breaks, then that can really go wrong and overflow the links. In terms of hashing problems, there have been some implementations that had problems with odd links where the hashing would turn out very lumpy, so that's kind of a hard problem to solve. Sometimes the hashing algorithms are too simple. In a lot of the top of rack switches, for example, the ASICs just use a subset of the bits in the source and destination IP addresses or ports or something, and then that can turn out badly if there's no variation. And then also hashing algorithms are typically limited in how deep they look into a packet. So, for example, many just work on the top source and destination headers, and they don't actually look into deeper fields like MPLS labels or VPNs or things like that. And then at the end of the day, even if you have a really good hashing algorithm, if you don't have any diversity in the input to the hashing function, then the output's not going to be very diverse either. So as far as the technology update, we've had a lot of first-generation things on the market, so everything from test equipment to optical gear, routers and switches started shipping last year when the standard was done. So we also have a lot of second-generation projects now that are based on 4 times 25 gig signaling. So the first generation is usually based on 10 by 10, so 10 lanes of 10 gig, either electrical or optical. There's a couple new developments that are going on, which are in the IEEE. One is that a copper study group was started in November. I don't see a whole lot of interest in copper cables and backplanes, but apparently there is interest in the IEEE from some of the participants. So I don't know if that will be interesting to the operator community. Probably more for the server and people trying to build blade servers and things like that using high-capacity backplanes. Now, the very interesting thing that's going on that has really developed in the last year and also in the past couple months is something called the 10 by 10 MSA. So an MSA stands for multi-source agreement. It's basically a bunch of people getting together saying, hey, here's a standard, we're going to build the standard, and we're going to make equipment that supports this standard. So there are lots of examples of MSA. 80-kilometer and 100-kilometer long-haul optics, there's no IEEE standard, but it's an MSA standard and it works, for example. The goal of this MSA is really to deliver a much lower cost 10 gig optic. The standards that were defined in the IEEE were chosen at the time to be the most cost effective. It turns out that that decision was incorrect, and there's a better way and a cheaper way of doing things. So what's happened really is there's been a lot of not only optics and equipment vendor support, but there has been an exceptional amount of network operators that have joined this MSA and that are very vocal. Google in particular has been a big supporter and driver of this MSA, and Facebook also just joined officially last week. So it's very good to see network operators actually getting involved very early on in what's going on with the optics and trying to push us to deliver things that better meet the cost and distance requirements, and that's really the goal here. And the IEEE is also going to start on a couple new projects probably this summer in July that will define the second generation of the official IEEE standard. So again, that's based on 4 times 25 gig signaling. So next up is the horrible slide that I have to show, and I keep updating it, and it gets denser and denser. I know you can't read this probably in the back, but really this is just a reference slide to take away. So when anyone's talking about stuff that's going on with 100 gig, either past or coming in the future, think of this slide. You can see the colors. So I kind of divided it into current IEEE standards, future IEEE standards, and then the MSA standards that are being worked on today. So again, think of this as kind of a reference on a roadmap. I was going to try something interesting. Maybe if you come up tonight to the social and you can ask me a question that is on this slide, then I will get you a free beer. So maybe that will entice people to read and remember the slides. So the point that I want to make... Is there a limit? Well, I'm not paying for the social, so no, there's no limit. So the other point that I want to make, which I've totally forgotten now. Okay, yes, in terms of roadmap, so like I was saying before, there's a bunch of technologies on the market today and then future technology. So the real second generation of IEEE standards really is going to come out in 2013. So what we have on the market right now is what we'll see for the next couple of years, and then we'll have the second generation of technology. So just like 10 gig, remember we started out with the 30-pin, 300-pin MSA, which was the big laser with the fiber jump cables for 10 gig, right? Now we have SFP+, so we'll see the same thing happen with the 100 gig over the next couple of years and as we develop new technology. All right, so enough on this slide. This is the slide that really has a lot more detail about what optics are actually available on the market today. Now the interesting thing is the pricing, and this goes back to what the 10 by 10 MSA is trying to accomplish with lower pricing. So I used the Brocade list pricing and abstracted that into just a dollar figure. So if you look on well, let's see, on the very end, the 10-kilometer single mode LR4 optic, that's the IEEE standard. It's very expensive because it's a very complex component and has a lot of circuitry inside that does conversion between 10 gig to 25 gig and things like that. The 2-kilometer MSA is really targeted to be about half the price of the 10-kilometer IEEE LR4. So that's really where the network operators have come forward and said, we don't need 10 kilometers, we actually just need about 2 kilometers, or maybe 4 if you can do it. And we can't afford to pay $150,000 for an optic. It's just too expensive. It's not going to work out. The other thing that I like to point out is the media type. So a lot of people ask me, do I need WDM infrastructure for the 10 kilometers or the 2 kilometer? No, it doesn't. It just runs on a pair of single mode fiber, and it does actually the WDM functions in the optics. So that's another reason why they're so expensive, is because, like I said, they are quite complex. All right. In terms of the router market, I just made a very simple slide saying, these are the router vendors that have equipment available that you can buy right now. This is the feature set that they support, and this is the optics that they support. So if you're interested in 100 gig, I would encourage you to talk to these vendors and ask them what their plans are, and more importantly, tell them what your needs are, because I think there's still a little bit of a disconnect as to what's coming out on the market right now and what customers actually need. So that's, again, why I'm excited about this MSA, because the network operators are so vocal in talking about their requirements and are really pushing the vendors to deliver them more than ever. Okay, in terms of optical transport networks, some of you have seen this slide before, and I keep saying I'm not an optical expert, so my knowledge is somewhat limited here. But basically, in the next couple years, we'll see 2 new tiers for optical transport come out. I don't think we'll see anyone making 100 gig waves available on the market today. A lot of the back end actually uses some 100 gig component on the front end, and then the optical gear uses 10 by 10 or some other aggregation technology to manage the waves on the back end. But eventually, in a couple years or whatever, when we have actually ODU4 waves on the market, you will eventually be able to buy a transport that runs at 100 gig from wherever you need to go. Okay, and then that kind of wraps up where we're going with the industry and what's new. So I want to turn over to Brent to talk about some of their thinking and their thoughts on operations.
Okay, so hey, I'm Brent Van Dusen. Just started with Limelight a few years ago, working in the network architecture team with Denver Maddox, Tom Coffeen, Guy Tall. So here's some basic motivational drivers. The first thing that I kind of want to talk about was the steady increase in hardware and software performance on our server platforms over the last several years. And it's to the point now where 5 years ago, probably when I started, an interface wouldn't exceed, a couple hundred megabits or so without the CPUs being floored. So we're to the point now, 5 years later, where we're filling up multiple 1 gig bonded ports, and we're actually starting to install 10 gigabit connected servers. We haven't quite seen full, capacity on those 10 gig connected servers at this time, but it's thrown some challenges in there with some of the flow-based hashing that we talked about, or that Greg talked about earlier, where we've got servers that are sending enormous flows, one particular destination, exact same flow. So basically, we end up with the lumpy lag kind of thing, where we've got multiple, 20 port lag with 10 gig ports in there, and maybe one of those ports will go up a gigabit or two higher than the other ones when we've got these extremely large flows being sent between servers. So, and then another thing is just the immense, operational installation and maintenance of that bandwidth that's installed using 10 gig interfaces versus going to something like 100 gig. So we basically just came up with this rule of thumb. If you're running with servers that are at the same speed as your core interface, fastest technology, then you're going to start running into these kind of hashing problems. And I think a lot of people probably don't use per packet hashing as much. I'm sure you've run into the same packet ordering problems that we have, and flow-based seems to be kind of the standard that everybody is really going with. So the technical considerations, really the biggest thing is just this MPO fiber for the short range, and the fact that it's probably not built out in most of the facilities as far as cross connects go. So it kind of limits the interconnections that we make between devices that are in the same cage or in the same location where it's easy to install and manage these MPO fibers. Connecting to other providers is going to be a little different because we're going to have potentially issues with cross connects not being installed, and you might have to go through hoops to build an MPO to break out fiber kind of patch cable where you could use 10 cross connects to actually connect two devices together over a patch panel, but that gets kind of complicated. So next slide here. So significant man hours saved. We're definitely talking about, if we've got one guy installing one fiber every day, and he's got to turn that fiber up, and he's got to make sure that's cleaned and the light levels are good and that traffic passes over the interface, without any problems and that kind of thing. So when we start turning up, 10 of these a week, it starts to become quite a burden on the installation provisioning staff. So, one of the big, benefits is basically being able to turn up 10 times as much bandwidth with one time, setup and everything with installing new fibers and stuff. Cross connects, we're definitely going to be saving money with cross connects. Right now we've probably got hundreds, if not 1,000 or so cross connects in use everywhere, and if you start talking about a few $100s a cross connect times a year's worth of monthly recurring charges, you're talking about hundreds of thousands of dollars in cross connects that you've got to maintain and continue to pay for. So obviously there's a benefit to going to some kind of a more dense media format so you can save on these cross connect costs. Router density is a thing that we've been looking at. It's easier to fit 100 gig with one port on a slot than to try and have 10 gig ports. So we're seeing a little bit of increase in density, up to 20% or so immediately, and that doesn't include future upgrades to the router platform, switch fabrics and whatnot that'll eventually lead to greater 100 gig densities and whatnot. So it's definitely going to increase the life of the platform. And then, a little bit about lag membership. We've run up against limits where, we can only have 32 members in a lag, and so we'd have to upgrade code to support a greater number of lag limits. And so that's something that we've run into and, have needed to upgrade software for. The future with 100 gig, I'm sure there's going to be a 100 gig limit, but I don't anticipate running into those as quickly, especially if we can make sure that the vendors can kind of foresee that we'll need to have lags. So it's not like we're going to completely get rid of a lag, but the membership will be reduced down to maybe 4 members in a lag or maybe 8, and then you're pretty much out of slots in your router to hook any more up. So I want to talk a little bit about kind of where we need the 100 gig. The first thing is just to make sure everybody's aware that we're a content delivery network and we don't really have the same requirements as far as capacity as like a typical carrier. So the greatest density of our interconnections are going to be from servers in a particular region to the users that are in that region. So we really have a very dense network within each individual region that we have a presence. So the biggest thing is going to be the connectivity from the servers to aggregation switches, then aggregation switches through the optical metro gear that we use to interconnect facilities in a region, and then up to the actual routing platform where we've got to build a very dense router core mesh to basically have capacity to all of our egress points that are in that region. The next biggest thing is going to be with the egress, the actual egress. There's going to be 5 or 6 of our top egress providers that we're going to be very interested in turning up 100 gig with, just because of the overall management that we talked about earlier with dealing with the number of 10 gigs that we're turning up to certain providers, and basically being able to cut down on that overhead by going to a faster standard. So that's going to be your peering exchanges, and then the larger peering and transit type providers. And then the last thing is going to be the backbone. The backbone to us is very important to our business, but it's not a core business product that we sell. You know, we're not selling transit to use up our backbone as much. It's just there to deliver content from origin servers, basically. So the need is there. I mean, we're definitely at multiple 10 gigs, but we're not at multiple tens of 10 gigs like we are within a particular region. So the main driver is going to be, you know, interconnecting facilities in a particular region where we can have lots of cheap space to put servers interconnecting into the more expensive, kind of more network-rich facilities. And so this is a really exciting thing for me, is the optical gear. That's the thing, if you touch it right there, okay. The optical gear is, I'm really fired up about this because, I don't know, right now we're using the Nortel Sienna filters. They're 88 channels and 50 gigahertz spacing. And I was really blown away by the fact that the 100 gig optical gear that's out now is actually capable of cramming 100 gigs into the same 50 gigahertz spacing. So what we're looking at now is an increase of our optical metro capacity on a single dark fiber pair from 880 gigs to 8.8 terabits. So that really, you know, cuts down on the amount of dark fiber. I mean, turning up fiber to other providers is one thing, but turning up dark fiber between facilities is a whole other ballgame that requires a lot more work and a lot more, you know, basically cleaning fibers, this, that, and the other, making sure that basically all the optical power levels are going to be okay over that fiber and that there's not going to be too much dispersion or chromatic aberration or any of that stuff. So, and all this 100 gig optical gear right now is going to be able to be used over the same fiber. There's not going to be like a new fiber standard that is required. Most fiber that's been installed for the last 20 years, maybe not 20, maybe 15 or 10, is capable of supporting the 100 gigs. So the density is a little bit less on the optical gear just because of the immense amount of technology that goes into, you know, multiplexing, you know, all these 100 gig circuits basically into one device. So we're looking at maybe some decrease in shelf capacity overall with what's available now. My vendors are telling me that by, you know, the middle of the year, late this year, we should have a second generation, third generation product that'll kind of get that back down in line with what we have now. That's really all I had to talk about, I guess, as far as the operational stuff. We're not really using 100 gig today, but we really have a need for it based on the, like I said, tens of 100 gig lags that we build. You know, we've got several hundred gigs coming from a server platform to a routing platform in another facility. So that just starts to become a huge nightmare with just dealing with all that stuff. And this whole 100 gig thing would really make that easier for us as soon as the cost gets in line with kind of what we're spending now on multiple 10 gig ports. And that's pretty much all I have. Questions for Greg and I?
I have one if nobody else has one. This is kind of a futures question, maybe for Greg. So given, how long has it been since we've been working on 100 gig?
Started in 2005.
Okay, so yeah.
6 years.
6 years, okay, well, we whipped it out. Sort of like Trail or something. Bam, it's done. So if you look in data center, like the really massively scalable ones right now, if people build a sort of traditional hierarchical architecture, so you have top of rack, you have some kind of aggregation device, then you have some router. If you look on those links between the aggregation device and the router, they're sometimes oversubscribed by on the order of 240 or something to 1 in the large data centers. Given that the uplinks are already 10 gigs, that doesn't leave you a lot of headroom if you have 100 gig. So what is it going to take us another 10 years to get to whatever's past 100 gig? Because it seems like there's already pent-up demand for 100 gig.
Yeah, so one of the questions that came up is why we're starting 100 gigs so late and why it took so long. So as far as what's going on in the future, Yeah, so so I'll kind of back up a little bit. The IEEE was hesitant to start a new project, in particular because of the way that 10 gig market played out, and the fact that a lot of people put companies into 10 gig, and then those companies went under because there wasn't the demand. And it's really 10 gig really now has been driven by the server edge, and that's what's driving a lot of the market growth in 10 gig. So now the IEEE, I think, understands the internet and understands the traffic demands and the growth pattern. It took a lot of education. There's, the IEEE, I mean, they're basically made up of component vendors and circuit vendors and optics vendors and things like that. They don't get how the internet works. So actually, Ted was there quite a bit. Jason Weil from Cox was there. Peter from NTT was there. So we did a lot of education, and Hank from AMSIX was also there, kind of explaining this is how the internet works, and this is internet exchange, and this is Sprint's network that carries a lot of capacity, and this is why we need 100 gigs. So in terms of the future, I think the next generation will come faster. Hopefully, a project being started in maybe in the next couple of years. The likely speed that's being talked about is 400 gig, just because it was really hard to go from 10 gig to 100 gig in terms of technology. And you can see a lot of the first generation stuff is still based on 10 by 10 gig. So as far as the future, 400 gig seems a likely choice based on what's going on with internal components and internal signaling within routers going from 10 gig to 25 gig. So it could be possible to aggregate 16 25 gig streams into a 400 gig Ethernet. That's what people are talking about for the future. And I definitely agree it needs to come faster. And we kind of surpassed the need for 100 gig already, except the market is kind of lagging behind. So I would definitely agree.
Good.
Hey, Greg. Thanks for the shout out for being there. Yeah, 4 years of root canal. You need to point out. I'm not against the 10 by 10 MSA thing. It's actually a good idea. I wouldn't say it was a mistake. I think we all agreed about 5 years ago that the packaging wasn't there to do it at the time, and now it's there. But MSA does not imply IEEE compliance. Down the road, maybe it'll be there, so people be warned just because it's cheap and says 100 gig doesn't mean it will always work the way you want it to with your other thing that is 802.3. That's why it takes so damn long to do anything with those guys.
Yep. I think that's a good point. But the point that I also like to make is that the IEEE likes to define Ethernet interface and speed standards, and they don't necessarily have to define when I say interface, I mean interface between MACs and PHYs and things like that, not physical interface. The IEEE doesn't need to define every physical interface speed that is out there. Just because it's not an IEEE standard doesn't mean that it won't interoperate. But yeah, to your point, Ted, I think you're right, and definitely, well, there are no cheap, Chinese optics right now, but I mean, you always get what you pay for, right? Eventually, I'm sure there will be cheap optics, 100 gig optics from Asia. But in terms of standards compliance, the MSA is a standard. So if you buy something that is 10 by 10 MSA compliant, then there's a good chance it'll interoperate.
Kevin Orman from ESNet. I'm not sure who to address this to. Greg, I think you might know the answers, but probably you're under NDA, so you can't talk about it. Maybe both of you are. You talked about the scalability of the shells, and I see that as a serious issue. Getting more 100 gig interfaces in a given amount of real estate in some expensive high-rent data center. Do you have any feel for how long it's going to be? And obviously, it's going to take a new form factor optics to get scales up to, say, 8 or 10 100 gig ports on a single blade. Do you think that's even going to be in the foreseeable future?
Definitely, that's where we're trying to go. And kind of to answer your question, there's a couple new form factors that are under consideration called the CFP2 and then the CFP4 and QSFP2. So these are all smaller and smaller form factor, hopefully less power media that will eventually allow us to get to 8 ports on a blade or something like that. And if you haven't seen a CFP optic, kind of to Kevin's point, they're larger than your iPhone. So it's a very wide media, and we only have 19 inches of board real estate, well, a little bit less, right? So we can only fit so much stuff on the front of the board. So we do need smaller optics, and that's definitely a big consideration. But like I said, with 10 gig, first we had the 300 pin MSA, now we have SFP plus. So that's a pretty significant size reduction in terms of form factor real estate, but also cost and power consumption. So all that stuff is a big consideration. And it's like anything. You can have cheap, fast, and easy, and you pick any two, right? So that's kind of where we are right now. But so that's why I point out that these two new projects are starting in the IEEE, is because we're already starting to think about not only the next generation of 100 gig signaling and interfaces, but also the counterpart, which is kind of the optics and what that looks like.
For the near-term future, in the pick any two, cheap is not going to be one of the ones you're going to get to pick.
Hopefully cheaper.
Anyone else? All right, thanks, guys.